Today, I will be discussing the implementation of authentic data in the middle level classroom. The first question you must really ask is, what is authentic learning? This is learning that incorporates activities in which students are involved with real-world problems that put them in the shoes of professionals in the field. I will be talking about most of this learning that incorporates students to think as scientists. Authentic learning engages students in inquiry, which is open-ended, and elicits the thinking skill that students must do to think about what they are learning. In authentic learning, students engage in collaboration, and they must discuss with one another about the problems that they are involved with and how they will overcome those problems that they are being handed. Authentic learning also incorporates student choice, and they are allowed to think about what they want to answer in terms of this real-world problem and what they want to study. I really like this quote from PBS which says, "Authenticity derives from engaging in non-linear inquiry that is unique to each learner." I like this quote because the term non-linear. This authentic learning really makes students think about what they want to study, where they're going to go next, and there is no straightforward answer about what to do in their learning and how they will go about doing it. Authentic experiences are those in which students go beyond taking in information, they go beyond memorizing information, they are able to make deeper connections with the content. Authentic experiences engage students in inquiry-based exploration and enable higher development of problem-solving skills. They address more complex concepts, and they potentially offer greater relevance to students' lives rather than traditional learning activities. Through authentic experiences, students are able to construct explanations for observed real-world phenomena. There are multiple types of data in which we can incorporate into learning. As students go from watching into open-ended discovery, there is a gradual release of responsibility in which students must take responsibility of their own learning and their own process within discovery. When choosing the type of data to work with, teachers must consider the needs that their students have that match the prior experience in which they have with data, and also must match the developmental needs of their students. It is suggested that as teachers, we involve our students with guided analysis and allow our students to become more comfortable with data and gradually release responsibility onto the students working with data continuously. We cannot simply throw our students into big data sets and hope that they swim instead of sink. There's a transition that must be made into making our students comfortable with using large data sets. The first thing that we can do is start small. Teachers must use data early and often and can use things such as data puzzles. These are opportunities in which students interact with data visualization, either as graphs or maps, and are a great opportunity for multiple concepts outside of science to work with data. This can include history involving mapping, maybe they're involving human sprawl, linking it to carbon dioxide emissions, or various other concepts. Another way to incorporate data small and working into big is having students create data similar to the data that they will be working with in larger data sets. This can be something like having students go out and collect their own data, such as collecting pH data in local ponds and streams and seeing how the pH or oxygen levels might change throughout the season or throughout different parts of a watershed. As we give students larger and larger data sets, we should ask them to predict what we think the data set will show us, to then observe if their predictions are correct, and explain, and this is really big with evidence, what they see through the data. Students should also be given practice, both guided practice and open-ended they're able to click around and use the data openly without having any control and without having any limitations in seeing what they can come up with. One of my favorite resources that I have found through my research is a research through NOAA. This institution has created modules that gradually releases the responsibility and makes students work through different graphs, through different analyses, to be able to work into open-ended inquiry. If you look at the picture on the screen, I have showcased level 1, which is the most guided level in this module. Students are asked to look at 2 different maps, which are 2 different seasons, and they must compare and contrast these 2 maps of the same part of the Pacific Ocean. In this module, students are looking at how fluctuations in surface temperatures change over time and how temperatures in the ocean respond to El Nino cycles. Jumping into level 5, students have been able to work through different levels and have had the gradual release of responsibility. And if you look at the objective, now students are designing an investigation using real data on El Nino to try to answer a research question of their own choosing. This means that students have student choice and are now more invested into the investigation that they are involved with. Through this investigation, students have the tools and have been prepped to be able to do the investigation on their own. There are many benefits of using authentic data within the classroom. The most prominent benefit is the promotion of data literacy and 21st century skills, which will be imperative for students to develop over the years. Because there is a lot of student choice within authentic data, engagement in these inquiry-based problem-solving opportunities will create critical thinking that our students need to develop. Authentic data also allows our students to become active learners, and instead of memorizing, it will improve their content mastery, and they will have a higher retention of the material. Because our world is becoming increasingly data dependent, understanding how to analyze data sets will become imperative. So introducing the power of problem solving of complex data is extremely necessary and a huge benefit using this data. Authentic data also incorporates modeling, seeing how there are different opportunities to model and being able to analyze said models. Authentic data also engages students and allows them to interact as the scientists that they are trying to become. Authentic data puts our students in the shoes of professionals in the field and allows them to understand what a person beyond high school might do in a real world situation. Within authentic data, there are challenges. Student-collected data through citizen science or through labs within the curriculum have lots of challenges. There's the potential for data to turn out unreliable. There is a large prevalence of anomalies within the data, but this creates opportunities for teachers to have discussions with their students about why there are anomalies, why there are errors in the data, and how we can correct them. This means that students have to have a greater resources available to them that a lot of schools do not have. It also means that they might need access to different parts of the world. Large scientific data sets collected by scientists require little skill to work with this data, but some students might consider this completely baffling. Real-world data might be messy, while some data sets are cleaned up and anomalies are taken out. Some are completely raw and might not show representations that match the theoretical models that we are trying to teach within the classroom. Additionally, specific software might need to be downloaded onto computers, and this can create problems with schools, especially if they are not one-to-one technology. mentioned before, students should have the opportunity to play around with data and be able to manipulate the data that they're being asked to use in their authentic data exploration. I opened up the OceanTrack software, which is one of the resources that students can use, which tracks different animals throughout different parts of the year. While playing around with the data, I was able to incorporate different maps and layer them onto my tracked animal data. I was able to see different layers like ocean temperature, ocean depth, and this one was the one that I found the most helpful, which tracks the amount of chlorophyll in the water. As you can see, a lot of the sharks congregate into a high chlorophyllic area, which I would assume means that there was a lot of prey for the sharks which are preying on that chlorophyll in the area. This, I'm assuming, might be maybe a chlorophyll or algae bloom, but I can definitely look into this, which students might be able to do within their authentic data exploration. Thank you for watching. I hope you've had the opportunity to understand the benefits of using data within middle-level education. I hope you have found this information useful and have been interested in multiple ways in which students can be involved with large data sets. I also hope that you have been able to see the data used and hopefully will go out and try to